Okay, so for the following transfer function, we have to construct the Bode plots. So the first thing we see is this is not really factorable. So we're just going to do we're just going to factor 400 though. So this will be s squared over 400 plus 80 over 400s plus 400. Oh yeah, and then we're going to let s be equal to jw. So this is just going to be jw squared, jw, and so on. Now we need this 400 to be inside of this squared bracket. So what we're just going to do is do the square root of 400 and then square all of that. And this is now going to look like the following. Right, sorry, this is now 1. Wait, sorry, yeah, this is supposed to be 1 now. Okay. So the square root of 400, that's just 20. And 80 divided by 400, that's 0.2. And 10 divided by 400, that's 0.025. Wait, sorry. Wait, no. Oh, yeah, sorry. It's supposed to be on the top. Sorry. Yeah. Okay, there we go. And now we're going to take log of this times 20. So this is going to be 20 log of 0.025 minus 20 log of JW minus 20 log of all of this. Okay? So now let's see what we can do. So now we're gonna pretty much wait. So this is gonna be equal to the magnitude. Now let's get the phasor. So tan inverse, the imaginary over the real. So this one has no imaginary, so this is just gonna be 0. This one is gonna be minus tan inverse of w over 0, and we're gonna take that to be infinity. So this is supposed to be just 90 degrees minus tan inverse. So this part is going to be the tricky part. So let's take this down here. So jw over 20 squared plus 0.2 jw plus 1. Let's take care of this squared. So this is just going to be j squared plus times w squared all over 20 squared, which is 400. This is just minus 1 plus 0.2 jw plus 1. So 0.2 jw plus minus w squared over 400 plus 1. Now we got the imaginary and the real components. So this one 0.2 w all over 1 minus w squared over 400. Alright, now we can start solving. Okay, so for the first one, it's going to be h dv and then omega here. So let's first get this one. 20 log 0.025. That's minus 32.04. Alright, there we go. Now we have minus 20 log jw. So that's just gonna match, that matches this one. But sorry, matches this one because it's a negative value. So this is 1. Oh, yeah, and we're starting at 0.1. There we go. So, oh yeah, and let me label these. So this is 20 log 0.025. This is minus 20 log jw. Okay, now the next one is this whole long thing. So that one, it can be represented by this one because that one's the one that matches close to it. So it breaks at WK. WK is whatever's being divided by JW in the square bracket. So it's going to be 20 in this case. So at 20, we do this, and then we go down like that. We have a slope. I'm going to just go through this and continue. So we have a slope of minus 40 degrees per decade instead of minus 20. And this is just minus 20 log JW over 20 squared plus 0.2 JW plus 1. Okay, and now we can draw our Bode plots. So let's add these two up first so we know where to start. So 20 minus 32.04, so that's 12.04. So at, sorry, minus 12.04. We're going to be starting here. We immediately start going down with a slope of minus 20. Yeah, so so this is what we call this. The slope for this is supposed to be minus 20 degrees per decade. So we go down with a slope of that value, and we just continue and continue until we hit 20. That's when we have to take this one into account. So let's find a point here. So it'll be y2 minus y1, which is minus 12.04, all over log of 20 over 0.1 equals minus 20. Oh wait, sorry. These are supposed to be in decibels per decade, not degrees. I'm making a lot of mistakes here. Okay, all of that should be fixed now. So 20 divided by 0.1, log of that, times minus 20, minus 12.04. So that means, and I get pretty much minus 58.06. So let me extend this all the way down here. So at this point, minus 58.06. Then after that, our slope decreases by minus, and now it's minus 60 decibels per decade. And that's the Bode plot for this one. Now for the phasor one, okay, so this one, 90 is related to this. This one is related to that. So minus 90 degrees. Okay, goes like that. So now we have to just, make the slope for this one. So we just follow this. Find 2 points. So 20 divided by 10 and 20 times 10. This gives you 2. This gives you 200. So 2 and then 200. We start at 0.1. So we do this. And since it's a negative value, we go down like this. And then we stop at minus 180 instead of minus 190. And then we move in this direction. Now let's draw our points. So we start at minus 90. We go from here to here. And now we go down. Oh wait, so sorry. We should also find the slope of this quickly. So the slope of that is going to be minus 180 over 0, all over log of 200, all over 2. And that's, let me see what that gives me. That gives me minus 90 degrees per decade. So the slope of this is minus 90 degrees per decade. Oh yeah, then let me also label these. I forgot to label them. This is supposed to be minus 90 degrees, and this is supposed to be minus tan inverse 0.2 W all over 1 minus W squared over 400. Okay, so this one, it decreases, and it has a slope of minus 90 degrees per decade. Let's find the point where it should end. So it'll be y2 minus y1 being minus 90, all over log of, we know it's going to stop at 200 because that's where the next change happens, and it started at 2, so it'll be 200 over 2, and the slope is minus 90. And let's see what we get. We get minus 270. So minus 270, that's where we stop at, and then after that we just continue straight. Okay, let me just draw this more properly. There we go. And yeah, those are your two plots.